Alright, let's take a look at some basic strategies for proving trigonometric identities. This is really important because I'll try to discuss all the strategies I can think of off the top of my head. And, the difficulty with this is deciding what strategy you want to use when trying to prove an identity. And the big thing is make sure to keep an eye on both sides of the identity as you're working through to see if you can ever find a connection between the two, and then work towards that goal of making the connection. Okay, so let's look at some strategies. The most basic strategy I can think of is to write everything in terms of sine and cosine and then simplify. So for example, if you see a tangent of theta, you might consider rewriting it as sine of theta over cosine of theta, So that's a very simple strategy. Sometimes it'll work, sometimes it won't. It's not always the best thing to do, but it's a good starting point for proving trigonometric identities. Write everything in terms of sine and cosine and then simplify and see what happens. Another strategy is to deal with fractions. Okay, so you may combine or split fractions with a common denominator. I'm not going to cover here how to find a common denominator and do all of that, but first of all, let's talk about combining. If on one side of an identity you have a fraction plus another fraction, and then on the right side you have a single fraction, then that may be an indication that you need to start on the left side and combine these guys and see if when you combine those you get this. And the way to combine these would be with a common denominator. So in this particular case you would want to start with this side because it's easier to combine usually to get a single fraction than it is to try to make a single fraction into two separate fractions. Okay? But let's take a look at one way to split a fraction. If you have x, well, let's use trig function. So tangent of x plus sine of x over sine of x, that's the same thing as taking tangent of x and sine of x separately, dividing by that common denominator of sine x, right? So you could split the fraction as such. So this is one way to create two fractions out of one, by splitting it over the common denominator. We're used to going the other way, right? If they have the common denominator, then we can easily get this. But now you can see that you can also split it using the reverse order there. Okay, another technique or strategy would be to use a Pythagorean identity. And when I say that, I mean use any form. So let's take a simple Pythagorean identity. Sine squared plus cosine squared of theta equals 1. So if you see a sine squared theta plus cosine squared theta, or any angle that matches, right? If it was sine squared of h plus cosine squared of h, that would also equal 1. You could replace that with 1. Similarly, you could use different forms. If you see a cosine squared of theta, well, if I solve this identity for cosine squared, I get 1 minus sine squared. So if you ever see a 1 minus sine squared, you could replace it with cosine squared and vice versa. So you can use all sorts of different forms of these identities. In fact, two that you should be very comfortable with is knowing that cosine squared is 1 minus sine squared and sine squared is 1 minus cosine squared. Okay? But you could look at alternate forms of all three Pythagorean identities and rearrange them in different ways to maybe help you. The key with the Pythagorean identities is they're squared. Make sure to pay attention to that. It's got to be both of them squared, okay? So I'll just warn you about that ahead of time. Another technique might be to multiply a fraction by a form of 1. So if you have something like this, maybe 2 over 1 plus cosine theta, well, you can make 1 plus cosine into 1 minus cosine squared by multiplying by its conjugate. So you might multiply this fraction by 1 minus cosine of theta over 1 minus cosine theta. And when you do that, you get 2 minus 2 cosine theta on bottom, on top. And on bottom, since these are conjugates, you get 1 minus cosine squared theta. And now, if you remember from the Pythagorean identity we just looked at, that's the same thing as sine squared, which might be useful because you've now changed the way it looks completely. Right? So the original fraction was this, and now it looks like this. So we've changed the way that looks completely by multiplying by a form of 1. Finally, we're going to look at factoring. If you have, you know, 1 minus cosine squared, especially with the Pythagorean identities, if you have a difference of squares, you can factor them as conjugates. So this would be 1 plus cosine theta times 1 minus cosine theta. That could be useful for lots of things as well. Alright, so it's difficult to grasp onto all these. The best way to learn these techniques is to practice proving trigonometric identities, and I mean a lot of practice, because you have to learn to use a correct technique, and you have to get very comfortable with the techniques. So go have fun.